This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello everybody and welcome to a new episode of our Industrial AI podcast. I'm Robert Weber and my co-host is based in Munich. Hello, Peter.
Good afternoon, Robert. Back to school day today.
Back to school. Yeah, we are a bit crowdy right now because we are celebrating our youngest son's first day of school today. So the family is celebrating and I am recording. So let's start into the news part. What do you have, Peter?
What do I have? Should I start already? First with Andrew Wing. So I ran into a video by Andrew. Andrew, who's the guy I learned, and probably thousands, if not millions of others, also including our dear listeners, machine learning. In my case, 8-9 years ago, Coursera, his famous machine learning course. So I ran into this video. I think it's actually, I should mention their name, Automate Forward Virtual Trade Show and Conference. And Andrew, in this case, as the CEO, founder of Landing AI, he explains his data-centric approach in industrial environments. Now, bottom line, his words, in my words, so to say, is that focusing on improving data quality has a higher effect than focusing on improving the model. That's what, he gives a couple of examples. One is that he explicitly looks into label inconsistency at the end of the line quality inspection with steel, but, could be the same for, the paint of a car. So I'll just share that with you. You can look at the complete video later. We'll share the YouTube URL with you. One domain expert, very important. There he or she is, my story, and we'll hear the domains expert again later. And it's always to think about, is the domain expert going to lose their job? No. Their job is going to be more important in combination with AI. So one of them, as an example, is putting one bounding box around an area of a number of minor quality spots. And another domain expert identifies each of them separately. Now, and we humans, we see, okay, one did this and the other that. They meant the same thing, but the algorithm doesn't know that, and that he gives us as one example on if you go through these kind of labeling, potential problems and you get rid of them in one way or the other, doesn't mean how you do it, then you're going to strongly increase the result of in the end of the model, of course. So Andrew Wang, we have been told before,
Yes.
Was it a Vietnamese person, I believe? I don't know who told us.
No, it was a guy from Germany who writes the books in Silicon Valley, and he has some friends, I think Vietnamese. Yeah, I think so.
So yeah. Right. So he suggested it's NG is pronounced Wang. So he's the AI guru. His famous quote, "AI as the next electricity." He has a number of new initiatives. One is Landing AI, computer vision in industrial environments. Would be nice to get him in front of our podcast, Robert. Let's take it as one goal in front of our micro in the next couple of months. Whoever is listening and knows a route away into Andrew, who has gone very strongly into industrial, if he learns that we have changed from German into the English American language, he may be interested in joining us. So looking forward to hear as well from you listeners, your experience with regards to exactly this, focusing on improving data quality, having a higher effect rather than focusing on improving the model. Maybe there's some of you who have already experienced it, who are now going to try it, or who knows, we'll be very interested.
Yeah. I think Andrew is invited by Bosch to an event in this September or October. I'm not sure. Maybe we should ask Katja Lauschkat, because she's the vice president for applied AI software business at Bosch, and she will come to our event in October with Sepp together.
Oh, wow.
Maybe she can give a connection or make a connection to Andrew. But I think it's very interesting with Andrew because he talks a lot of small data.
Also,
in the past, he was he was a guy with big data, and now he talks a lot about small data.
I don't recall that he ever was the marketing. Because I've always said from the beginning that we're doing this, for me, always the big data was kind of a, let's say, marketing exercise of the hyperscalers. I don't say that big data doesn't exist. It certainly does exist. And there's certainly a, let's say, a complete environment around doing good things with, if you have. But here you have, Andrew, who knows from bottoms up, like Sepp Hochreiter, like Jürgen Schmidhuber. He's one of those guys. And he has been saying now for quite a while that, if we want to move on with artificial intelligence, and of course we want to, he leaves open in what direction. But if we want to improve, and then compares with, with children, you talk about your child having gone to school. If we go back even further and we say, a child looks at, mother, daddy, looks at whatever, a dog, and maybe after 5 or 10 times having seen a dog, the child knows after 5 times this is a dog. And as long as, I think that's what he's been saying, as long as we need, 10,000 images of a cat before the machine learning model understands that it's a cat, that's what he has been saying we need to improve. So yes, you're right. And it's great to hear him say that we need to do more research into that direction as well.
To our German listeners, I recommend the episode with Sepp Hochreiter where he talks about few-shot learning. That's nearly the same what we're talking about in a moment.
Yeah.
What do you have else?
Something completely different. AI in text. I think there was I think it was the last 1 or 2 weeks, seeing all the German language, English language inputs, also the American ones. So I think most of you may already have heard, actually, for those who have not. So the French tax authorities, they started using AI to identify unregistered pools, swimming pools. Mm-hmm. It's an application developed by Google and Capgemini. That's a French IT company based in Paris, I believe. So they use aerial images, and then a machine learning algorithm recognizes pools, right? From the top you can see. They connect it to a land registry database. Outcome: unregistered pools. Will be rolled out nationwide. They did a test of flagged taxpayers, and 94% of them actually did not have their pool registered. So then they said, okay, we're going to use it. My first feeling was, Big Brother is watching you.
Yes, I think so.
That is, there you go. I'm not sure if we actually have legislation that is related to having a pool or not and then paying. I think we're a little bit each still different within the countries of the European even. Also, despite the fact that France and Germany, many, many times try to synchronize things. So I think it's the old discussion. On one hand, the state bureaucratic system is bad. Certain people say that. And I think we see way too many global developments in that direction. So that, I believe, is not good. On the other hand, and I'm a big supporter, we are the state, as long as we can in parts of the world be democratic. So I'm perfectly okay with us agreeing in a democratic way on the rules and regulations. So anyway, the French are not the only ones. I saw a link to an Antwerp, Belgium university study, and they said that 18 EU member states, so that is about 2/3 of all the European Union tax administrations in the EU, make use of artificial intelligence, machine learning, for actually, automating the performance of their fiscal missions. So I can only say, I've been, a small independent consultant for, 3-4 years now. I have not been called for a tax audit.
No, I have no pool. I'm sorry for that. Yeah, my neighbors also have no pool.
And I have no pool. No, I don't have the pool either. But anyway, no. The point I'm making is that I've always been convinced that the way and so the researchers from Antwerp kind of confirmed that Germany was included. Almost the center of Europe is all, tick off the use, of course. They have the data, so they can run the algorithms on it. And I say, that's fine with me, but it's always this discussion. Doesn't mean that we should allow everything, not at all. But I always knew that it doesn't make any sense that they would not be looking into the data. Right? You look at the pool of, small, consultants, one person. Are they in their first 3-4 years, in the middle, in the later? What is their income? What is their cost? And of course, a human can do that. That's what they probably did in the past. But now let's say you have 10,000 of them, and all you do is you start making a model, and then you run each of them separate through the model, and then you see, how far is everybody away from the model, right? And then outcome, 100 are completely different from the 10,000. And then it's very clear that, some person in the tax authority maybe looks at it, 50 go out, and the 50 ones, they then get an invitation, which I'm not asking for that kind of call. But if I'm ever going to get it, I have been doing my taxes in good faith.
Absolutely.
So.
Absolutely. But you have a caravan, so maybe for caravan too.
Oh, well, don't say too many things, Robert. Actually, not a caravan. Although in Germany, everybody knows that every Dutch person has a caravan.
Has a caravan, yeah.
That's the saying that goes by. Yeah, so it's a completely different thing. I just did want to share it again. I think it's, I hope that's what our English language listeners do like. This is about industrial AI, but we do, look towards other areas every now and then.
Absolutely.
It's only to trigger each of your listeners, minds and brains that are in industrial as well. You're going to hear new things and say, "Oh, what can we do with that new technology, with that new approach in our own areas?"
And some CEOs still have pools at their factory, so maybe you have to close these pools now.
Yeah, well, as long as they're in France, they should be careful.
As long as they're in France, yeah. I have an interesting article on the topic, and the topic is, can AI be destroyed? We're talking about algorithmic disgorgement. Do you ever heard about that?
No, I hadn't heard about that term before. No.
Me too. So the idea, the question is, can AI be destroyed? When a company did something bad with the AI and the data set. And I got some expert advice on that, and we are going to do an episode on that because I think that's very, very interesting. Can an AI be destroyed? I put the article into the show notes.
I started reading it, but for whatever reason couldn't finish it because it was about data that has been used in an improper way, not according to GDPR.
Yeah.
Well, it's looking forward to. I mean, in where we are based in Germany, that's where GDPR is from, and now it's European, and a couple of other countries in the world follow similar, legal data approaches. My first thought was, right. If that would have happened here, I would have thought, okay, there you go. Something like is what you say, it has to be taken away and, deleted, destroyed. And then I think the article is about, you say, that's not that easy, or?
Yeah, that's not that easy. My second topic is the Xbox. Have you ever heard about Xbox?
Maybe it's one of those games. Notebook. Well, Xbox. You've been using it or not?
Yeah, I have an Xbox at home. And then there's an Xbox manager, and he wants an AI for quality assurance of the games.
Oh.
That's very interesting because then I thought this is also very interesting for our industrial processes, and they also could benefit from this idea to have an quality assurance by AI in software and in at games.
Oh, that's what he means. He means the quality of the program at a programming language level, or. So the program is not supposed to crash, like, for example. That's what exactly. It's not about the quality of the story, but it's like if you buy it and you want it be able to play it for 100 hours without crashing or whatever.
Without bugs or problems in the game. Yeah. That's very interesting.
I mean, it's always been weird, right? I mean, since how long do we have software? How long do we have software B2C, B2B? Maybe 25 years, 30 years? I have no idea. Yeah. And, as it started, especially with these kind of games, I believe, and maybe although, you've been there before me, it was then, it was weird because we gave money for software and it was not always working, right? And that was a very weird thing because we had been buying shares and cars and tables. And when there was something wrong with him, well, we called up or we sent him back. We got a new one. But with software, that was always has always been different somehow and still is then maybe, right?
Yeah, because games are getting more and more complex. Mm-hmm. And these games are like films, like movies. Mm-hmm. The costs of these games are millions of US dollars or euros. Yeah. And I think it's very interesting. He talked to a Microsoft AI guy and asked for help to have quality assurance. I think that's pretty interesting. We should have this on keep on mind what Xbox or Microsoft is doing there.
Yeah. Another thought I have immediately, because as I said with the software, I did refer to, let's say, the consumer games that I do not know. Mm-hmm. So, you would need to tell me if maybe 10, 20 years ago, I don't know when you started, it would crash maybe every 10 minutes and today not anymore. I do not know that. Of course, in this case, it's the other way around. We have our industrial systems that are not supposed to crash, and which I know and can confirm is the case, that they do not crash at a regular interval. So I guess, of course, 1 in 100, this may happen, but it's not, when we are looking at predictive maintenance and, improving the OE of our production lines, we are not taking out, problems of equipment necessarily, right? And also including not necessarily. So it's a bit of a long thought maybe, but I can very well imagine. And in that case, the computer games industry could learn from industrial production how to improve their quality.
Yeah, and we talked to Tristan, and he told us that the industry should address the gaming industry to learn from the gaming industry how to use AI. That's interesting.
Okay,
both sides. Yeah, and I think it's very interesting because he dreams about a AI bot, and this bot should check the software, and at morning he will generate a report, and then you can see where are the bugs in the software. I think it's a dream, but I think it's very interesting. I think the gaming industry, there's a lot of money in there. The ideas should be realized. Yeah,
very good.
Do you have anything more?
Yeah, one final. I read from a leaflet from a company called Explain Data, and it goes in sync with an article I also started on towards data science. Those of you listeners who know the website newsletter, and it said a production parameter that correlates to subsequent failures does not necessarily mean that this parameter causes the failures. And I hear from my former industrial data intelligence startup colleague, Albert Kroon. He was in our podcast a year or two back, I think, where we were dealing at that time also with root cause analysis. He would always say, and now all together, correlation does not equal causation. And he said it so often. And that seems to be kind of a fun thing to do, that people who know about, this topic, typically coming out of statistical, maybe mathematical environments, that do the same thing. So continue then the Explain Data leaflet. I don't go too long, but here's a nice example. So those of you that have not heard about this fact. So causality versus correlation. An example. So gray-haired people often wear glasses.
Why you talk about gray?
I didn't give that. That's the example out of the brochure.
Okay.
That's the correlation. But glasses do not cause your hair to become gray.
Sure.
Nor vice versa, sure. Yeah. So there's a common cause for both hair color and the wearing of glasses, which is age. So the older you get, the more likely you are to wear glasses and get gray hair. So for those of you listeners that do not know us, Robert and me yet, only from the podcast, I wear reading glasses only, but I am gray. And Robert wears glasses, right, Robert? But you're not.
Yes.
But you're not gray.
A little bit.
A little bit already. There you go. So there we have one example, actually. So anyway, the point is, so for such cases, Explain Data, they provide patent-based procedures which originally were developed in the healthcare industry and based on extensive patient data. Now, think about industrial data, exactly the same, and that's what we're going to be talking about. Algorithms extract a small set of potential causal factors from millions of observed correlations. And these hypotheses then for potential causes can be easily evaluated by here he is again, domain expert. The second time today. Yeah. So there she is again, my story, the role of domain expert in times of AI has become more important. Yeah. Details on this very topic, we will get a relation to industry, as I said, in October-November timeframe, after I will have had an interview with Michael Haft. He is the Explain Data CEO. Until then, closing off, for those of you, as I said, haven't been into this subject, let me refer to the Tyler Weigen spurious or seemingly correlations. We'll put the link in the show notes. I give you two examples. So the US spending on science, space, and technology correlates for 99.79%, so that's almost 100% for the last couple of years, a very specific time frame, with suicides by hanging, strangulation, and suffocation. You may need to listen to this again, but I give you quickly a second one. I'll speak slowly. The same with the per capita cheese consumption, not of the Dutch people. I think it's global.
Okay. Not your Dutch people.
It correlates with the number of people who died becoming tangled in their bed sheets at a correlation of 94.71%. So now you can understand those are correlations, but they are not causations. One of the two was not the reason for the other one. So I wish you a lot of fun going through this website. For those of you interested, Tyler's Spurious Correlations are also available as a book.
Perfect.
If we have nothing else, then
we start. We in the main part we have now a very interesting interview with Jochen from Werk24. He's our guest, and he has a smart solution for reading information from technical drawings. I think it's very interesting for our engineers and for our people in industry. I thank you, Peter, for this episode.
You're welcome.
Greetings to Munich and to our listeners. Enjoy listening to our main part with Jochen.
Have a nice time. Thank you, Robert. Talk to you again. Bye-bye.
So our next guest is Jochen Mattes. Hello, welcome to the podcast.
Nice to have me.
You are the founder and CEO of Werk24. Please introduce yourself in a few sentences, and what is Werk24 and why is it German Werk and 24?
Well, that's for historic reasons, I believe, Werk24. We had the domain available, so that's the reason.
Okay.
Werk24 is really specializing in extracting information from technical drawings. So you're in a situation that you have the ground truth about what you want to manufacture, and that is stored on a technical drawing. The problem with that is that it's in a format that is very difficult for machines to read, and what we do is we translate difficult format to read into something that's very, very easy to process for a downstream process. Once you have that, you can do a lot of things with it. You can check whether it's the part is suitable for additive manufacturing, or you can check whether it's feasible with the machines that you have.
So AI reads technical drawings, correct?
Correct.
Why is it so important? I think the most things are digitalized and you don't need more drawings.
We would hope so. The reality is a bit of a different one. So in reality, what we find is as soon as a documentation leaves the building, it's normally converted into a technical drawing, it's converted into a PDF, into a TIFF image, and that makes it very difficult for the next person who receives that technical drawing as a supplier, for example, to actually process that technical drawing automatically again. And that's why you need to have the work preparation units in these companies to extract that information again and make that available in the format that the customer or the manufacturer, the supplier needs at the end of the day.
But how long is this business model still a good business model? 10 years, 15 years?
Well, that is a very good question. It's very difficult to answer. What we see right now is that a lot of new technical drawings are still being created on a daily basis. And the average age of the technical drawings that we process is less than a year.
Less than a year?
Less than a year. So it's very, very current.
So what are the standards actually? And so I come from computer-aided design, but that's long time ago. We talked 30, 40 years ago. So computer-aided architectural design. So what are the standards these days? You already mentioned PDF and TIFF, I believe. But what about engineering drawings? Are they in the same format today, even when they go out as a digital design, so to say?
We differentiate between in-house and out of the building. Basically, in-house, you have a very high integration between the individual processes in the organization, departments, etc. And that's when you use high-quality data formats. But as soon as this drawing, that information actually leaves the building because you want to purchase it, because you want to manufacture it by a third party, then you're going into something that is very easy for the other person to open again. Because, if you're using a PDF, you're very, very sure that the other party is able to open that file. And that's why PDF, I think, is still around, or technical drawings as PDFs are around and will be around for a long time.
Let's talk about the technique, about the AI. What is the technical background of your solution?
So what we have is two components that really play together. We have a machine learning component that extracts the information from the technical drawing in such a way that it looks at the individual features on the drawing. It recognizes certain shapes. It makes interpretations about what that could mean.
How do you train this model?
It is trained automatically. So what happens is the technical drawings that are being processed, they're being labeled by the AI itself. Then they're flagged for manual verification or automatic verification. And that information then goes back into a training set. Then we do a training loop. And then 2 weeks later, we actually have an improved version of the AI that is now able to just perform better on the data set that is coming in.
So it's a combined unsupervised, supervised. Somewhere in the loop, you need a human being to say, this is a door, and this is a human, and this is a human, and kind of, or somewhere.
Absolutely. So the system understands what it understands, but it also understands what it does not understand. And whenever it finds something that is new, it calls in the human and go like, hey, please tell me, what does that mean?
So the system calls you as the people from Werk 24 or the person who did the drawing?
Well, the person who did the drawing is very difficult to reach. But what we can do is we have two offers. Either we as Werk 24 and the Werk 24 employee jumps in and checks what the drawing actually means. Or our partner, our customer says, okay, I have my own people that have very specific domain knowledge that are just going to do a better job on really understanding what this specific part now is.
I interrupt you when you explain the machine learning. Can you explain the technical process once again?
Yes. So what we have two separate components. One is a machine learning component. One is the engineering validation part of our technology. Now, the machine learning model constantly makes interpretations of the technical drawing, and then it calls up the engineering part and says, does that make sense? Does this interpretation make sense from an engineering point of view? And if it doesn't, it's like playing ping pong. It goes back and forth until these two systems agree on a valid interpretation of the drawing from an engineering point of view. Only when that is passed, we send the data back to the customer.
Is that like adversarial approach, or sounds like it? Two algorithms fighting until they find the perfect or agree upon the solution, which then must be an engineered solution.
The second aspect that we have in the engineering part of our solution is a lot of rule-based stuff, because you just have to follow the norms that are specified, and a creative interpretation of the norm is probably not advisable, even though we see that very often in drawings.
maybe you want to share with us an example, who, as a typical customer of yours, comes into the office 9 o'clock or stays in the home office and opens up. What is that person doing? Just gives an example of how is an engineer using your tool.
The easiest example that I can give is our customer LaserHub. They're an online manufacturer. So what you do is you upload a technical drawing, you upload a 3D model of a part, and in a couple of seconds they tell you, what should it cost? And then if you like it, you can really order the part. In the background, they're also selecting the right supplier for that. So they're really a matchmaker.
It's a platform.
It's a platform. Absolutely. In order to do that correctly, in order to be able to calculate the correct prices, you need a lot of information from the technical drawing that is not contained in the 3D model. You need the tolerances, you need information about the threads, and much more. That's where we come in. So what LaserHub does is they send us a technical drawing, we extract the relevant price drivers, return it to them. They then do the price calculation and offer the result to the customer.
But the company who will produce this one piece is never in contact with you or with LaserHub?
They are in contact with LaserHub.
Okay.
They are not in contact with us.
Okay. So they must trust your solution that this is correct.
LaserHub must trust our solution and our return values, because they make the price. And when they make the price, they stand by the price. Another example that I can give that is more on the side of the manufacturer is we have an injection molding company as a customer whose name I sadly can't mention, but they do feasibility analysis of incoming technical drawings. A lot of these technical drawings were originally designed for CNC manufacturing and are not necessarily suited for injection molding. Now, what happens there is previously you had a work preparation unit that was checking the technical drawings, filtering out all the things that were not able to be produced with the technology that they have. And then they were trying to reach the original person, which of course is a process that takes weeks, because when you call that person up, they're not going to be answering the phone. It is a painful process. Now, with the automation that we have in place, we can tell the customer within seconds that he's trying to order a part that cannot be manufactured, and here are alternatives, that modifications to the technical drawing that would allow us to actually start the manufacturing process.
You facilitate the market. We talked before about a paper digitizing, feature extraction. But here you have another example. This design was never meant. It was meant to be for NC machines, you say. Now, since a couple of years, we have a new technology, which we didn't know. What should I say? 20 years ago, something like that, 25 years ago. And you again, so you do this, what is it, this transformation, so to say, when Robert, when you asked about how long are you going to be doing this, so to speak, you already said you don't know, because maybe tomorrow there's again another technology and whatever design, or which I will come back to though, because so the companies that learn from your capability, so it's those companies where in my time, computer-aided design, AutoCAD, whatever it is, thousands, you know them, I don't know them today, but they must be thinking along similar lines like you do. So maybe some of them, they will design your AI-based feature extraction capability into their new products. Is that, you don't have to be positive about your competition, but is that something that we can expect in the market, the same capability, similar capability?
So we're offering our services as an API directly in the pursuit of convincing all these software companies to integrate us as deeply as they want. So it's really an offering that is available to everybody. He needs to have the information from a technical drawing. Certainly, we cannot prohibit anybody from actually developing it themselves. What we've seen in the past from large manufacturing companies is that it is a very long and painful process if you're trying to achieve that within the company for a couple of reasons. One is access to data. So if you train that a model like this, a model like ours, specifically only on your data, then it will work on your data. But as soon as you get a drawing from a supplier, the AI will just raise its hands and say, I'm on holiday now.
Overfitting, typically, right? Yeah. So how did you come to concentrate exactly on this part of this transformation? Is there some nice story out of your youth or out of your studies, or where did you decide there must be something more than just you doing something?
For my previous employer, I was in touch with a lot of manufacturing companies in Germany. And one day I went into an office, watched an engineer print out a technical drawing in A0, hang it to the wall, and spent 45 minutes finding the smallest tolerance on it. And for me, that was really a key moment where I said, we cannot waste the lives of our engineers like this. They can create so many interesting things. Let's remove all this burden.
Where do you get the data?
We get the data from our partners. We have a range of online manufacturers.
But you can use from different manufacturers the different data. Is it allowed?
Absolutely. So the nice situation that we're in is that we get over 100,000 drawings per month from very different data sources, and that allows us to really develop a robust technology.
So tell us a bit about the solution. You say 100,000 drawings. It sounds like terabytes, zettabytes, I don't know, that you can share if you want to. So is that then in a cloud solution? And does it work in the cloud, or does it work also on site? And if you talk about that, how do your customers, related to Robert's question, how do they feel about their data, being put into, if so, the cloud?
So it is a cloud solution, and the way we structure that is we have the right to store the data, the technical drawings, for up to 3 weeks. After these 3 weeks, we completely delete everything that we had, because we need that 3 weeks to A, do bug fixing, and B, to include the technical drawings into the machine learning models. After that, we don't have any use for the drawings anymore. We can just discard them. That is something that is very helpful for a lot of companies because they know after 3 weeks the data is gone. Now, looking specifically at technical drawings, people have less of a problem with technical drawings because they're designed specifically for sourcing purposes. So they're leaving the building anyway, and that's why this hurdle is not as high as you would have it or expected with actual production data, for example.
Sounds a little bit like, federated learning is such a hot topic. Of course, it's the algorithm also probably, I don't know, but maybe extracting the features out of the data, the algorithm coming to the data, and then I take the features, maybe, I don't know, and then I go again, and then at least those people that are afraid about having their data in the cloud say, okay, my data stays here. Sounds a little, it's maybe a different approach, but there is some similarity between the two.
There's certainly some similarities, specifically if you look into the customer groups. Mm-hmm. So if you have customers that are really in high technology, then they feel a little bit less comfortable sharing their data, and then you have to find a different solution. There are different ways of how to approach that problem. Federated learning is certainly one that sounds very, very interesting.
And you receive constantly these drawings, and you train the models constantly with new drawings, correct?
Correct.
So every 3 weeks you get a new model, or what is the idea?
Exactly. So we always collect 2 weeks worth of data. After 2 weeks, we start a training iteration, and then a couple of days later, we have that then online.
Is it an application or an app I can download and put it on my PC, or do I need a special edge device or something?
Our primary goal is to be integrated seamlessly into other software. That is the ideal situation. So we have an API that allows you to communicate with us through the WebSocket communication. The other way of communicating with us, if you say you don't have a large volume and it doesn't make sense to go through like integration costs, we also have a web interface that would allow you to upload a couple of hundred drawings, or even a larger volume when you say it's just once, and then after that it's done. Then we have a web interface that would also allow you to interact with us.
And what is the business model? Is it a licensed business model, or what is the idea?
So we have two components when we talk about that. First component is what capacity do you need? Some people really need to have the response within a couple of seconds. Other people say next week is fine. That has an effect on what capacity we need to provide, and that also has an effect on pricing. The second component that we have is we work on a volume basis. So, of course, if you're trying to analyze 1 million drawings, then it's going to cost a little bit more than if you're trying to process 2 drawings.
You mentioned the API. Is it a dream or is it a goal to be in this software, or are you already in this software?
So we have a range of customers, a range of partners that already integrate us into their internal process flows. LaserHub is one of the examples. There's also Creatize to be mentioned. There is Diamonex, for example, which is a company from the Netherlands that does additive analysis is an end-to-end manufacturing platform for additive environments. They also basically work with us together, and the integration is very tight.
I think that's very interesting that you mentioned these platforms, LaserHub,
Creatize.
Are these your key customers and traditional machine building companies are second, or is there no difference?
There is no difference. The nice thing about the online manufacturers is that they're very keen on bringing their name out, so they allow us to mention their name. Whereas if you have a lot of German Mittelstand manufacturing companies, that attitude is a little bit of a different one. So sadly, we cannot list them on our website, but these two groups exist for us. They have different needs. Online manufacturers, software companies, basically. So they don't need a lot of software support from us, whereas traditional manufacturers might not have really large software development units. So here we have to provide an adjusted service. But they're both very interesting customers for us.
Tell us a bit about your company. Where are you based? Where did you originate? How big are you? How many colleagues do you have looking for new ones? What kind of jobs?
So we are located here in Munich, just downtown Munich. I believe one of the best places in Germany, but we can debate about that. We're a very small company still. We have about 8 people. So far, we've been a remote-first company. Now we're changing that a little bit because we're bringing people a bit closer together in a larger office here in Munich. That's signed yesterday, so it's a very current development.
Congratulations.
Very good. But you're targeting what? The European market, global market, specific countries, specific languages? Or
We have customers globally. The preference for us is the European Union because it makes it easier to deal with the data.
Why?
Whenever you go into a different environment, you have the situation that there's local laws that you just need to consider. And there is a process that we can go through if a customer says, I have a large volume and I want to really support the legal checks that we have to pass in order to provide that service in my country. But the customers that we're focusing on are, of course, the ones that the low-hanging fruits in quotation marks, the ones where the interaction is very easy, very fast, because all the legal questions have already been answered.
Sounds great. A little bit under the hood, maybe. Like we talked about the level of, supervised, unsupervised. Below it, we have 25 years of LSTM or any kind of other, the ones listening with a little bit more detailed interest. What is the kind of specific algorithm, direction, developments that we see lately happening that you are looking at using?
That's where our secret sauce starts to really come in. The topic has been explored since 1988. So there's a lot of academic research that's been going on. What we realized is that we read the papers, we took a different direction. We took a completely different direction because we were convinced that how we solve it, which is fundamentally different from what we've read in the papers, is a different way. And that makes it a bit difficult to talk about it.
Does it mean that you're going for any copyright, any legal patent, something like that, or? Okay, you don't need to answer. No, that's okay. I mean, I can only confirm that if you're sure that is true, then make sure that some legal lawyer will confirm, and because then it goes a little bit into your question of a business model. But that was maybe never your thought. But I'm not going to suggest that you should do that. But it sounds good. Sounds interesting. Sounds like there's in addition to the millions of papers that we see these days, and nobody can read all of them, for which reason we do use AI to extract the features out of the papers. Maybe not the same way as you do it, but it sounds like there's even other structural ways of doing things. Sounds really very interesting.
Yeah, thank you very much. It was a pleasure to have you here on the podcast.
Thank you very much for the invitation.
And good luck with your business.
Thank you.